According to National Electrical Code Section 110.26 C concerning entrance and egress requirements for electrical equipment rooms, particularly those housing equipment rated 1200 amps or more, the code stipulates specific conditions for personnel safety. The central question revolves around the interpretation of the statement regarding the location of the entrance when the exception allowing a single entrance is applied, focusing on the distance from the equipment to the entrance. The code mandates that for rooms containing electrical equipment rated at or above 1200 amps, 2 entrances are required at each end of the working space to ensure a safe means of egress in case of an emergency. However, exception number 2 provides a conditional allowance where the working space is doubled. In such instances, only 1 entrance is required. The critical stipulation accompanying this exception is that the entrance must be located such that the edge of the entrance nearest to the equipment is at least the minimum clear distance specified in Table 110.26 away from the equipment. The core point of contention lies in whether the entrance is required to be a minimum of 3 feet away from the equipment or if it must be no further than 3 feet from the equipment based on the distances provided in Table 110.26a. The correct interpretation is that the entrance is supposed to be no further than the distance specified in Table 110.26 from the equipment, which in many common scenarios might indeed be 3 feet. This requirement is designed to ensure that personnel can quickly and safely access the entrance for egress without navigating an excessive distance within the equipment room. The aim is to minimize exposure to potential hazards during emergencies. This interpretation ensures that the entrance is readily accessible, aligning with the overarching safety goals of the NEC. Let's delve into the specifics to understand the rationale behind this requirement and how it applies in practical scenarios. Firstly, the NEC prioritizes safety in electrical installations, and the provision of adequate egress from equipment rooms is a crucial aspect of this. The requirement for 2 entrances in rooms with equipment rated 1200 amps or more is primarily intended to offer multiple escape routes in the event of an electrical hazard, such as an arc flash or equipment malfunction. Secondly, the exception allowing a single entrance when the working space is doubled is a conditional relaxation of this requirement. This is permitted under the assumption that the increased working space provides a safer environment, reducing the likelihood of personnel being trapped or hindered during an emergency. However, this relaxation is contingent on meeting the specific condition regarding the entrance location. The stipulation that the entrance be located such that the edge nearest to the equipment is at least the minimum clear distance specified in Table 110.26 away from the equipment is a critical safety measure. Table 110.26 provides minimum clear distances for working spaces about electrical equipment, varying based on voltage levels and conditions of the installation. For instance, for equipment operating at certain voltage levels, the minimum clear distance might indeed be 3 feet. In such cases, the entrance must be positioned no further than the specified distance from the equipment. This ensures that personnel can quickly reach the entrance without having to traverse a significant portion of the equipment room, reducing their exposure to potential hazards. The purpose of this requirement is not to mandate that the entrance be a minimum distance away to create some sort of buffer zone, but rather to ensure accessibility and minimize the distance one needs to travel to reach safety. In practical application, this means that when designing or evaluating an electrical equipment room, one must first determine the applicable minimum clear distance from Table 110.26 based on the equipment's voltage and installation conditions. Then, the entrance must be located such that the closest edge of the entrance is no further than this determined distance from the equipment. This ensures compliance with the NEC while also promoting personnel safety. To further clarify, consider a scenario where an electrical equipment room houses a 480-volt distribution panel. According to Table 110.26a, under certain conditions, the minimum clear distance for working space might be 3 feet. In this case, if the room qualifies for the exception allowing a single entrance due to doubled working space, that entrance must be located such that its nearest edge is no more than 3 feet away from the distribution panel. This arrangement ensures that anyone working on or near the equipment can quickly and safely exit the room in an emergency. In contrast, If the interpretation were that the entrance must be at least 3 feet away, it would imply creating a buffer zone that might not always be practical or necessary. The code's intent is to ensure accessibility, not to impose arbitrary spatial separations that do not directly contribute to safety. Moreover, such an interpretation could lead to confusion and potentially compromise the overall safety design of the equipment room. Understanding the nuances of NEC 110.26 C and its exceptions is crucial for electrical engineers, contractors, and inspectors to ensure compliance and, more importantly, to safeguard personnel working with electrical equipment. The key takeaway is that the entrance must be located to provide the most direct and unobstructed path to safety, adhering to the maximum distance requirement as specified in Table 110.26a. Let's consider a different scenario to further illustrate the practical application of this code requirement. Suppose an electrical equipment room contains a large motor control center operating at 600 volts. According to Table 110.26a, the required minimum clear distance for working space in front of the equipment under certain conditions is 4 feet. This means that if the equipment room meets the criteria for the exception allowing a single entrance, that entrance must be located such that the edge of the entrance nearest to the motor control center is no more than 4 feet away from the equipment. This arrangement ensures that personnel can quickly and safely access the entrance without having to navigate a long distance within the equipment room, minimizing their exposure to potential hazards during an emergency. In this context, it's also important to consider the overall layout and design of the equipment room. The entrance should be positioned in a location that provides a clear and unobstructed path to the outside without any obstacles or obstructions that could impede egress. Additionally, the entrance should be adequately sized to accommodate the expected number of personnel who may need to use it in an emergency. Furthermore, it's essential to ensure that the entrance is properly marked and easily identifiable, even in low light conditions. This can be achieved by using appropriate signage and lighting to highlight the location of the entrance and make it easily visible to anyone in the equipment room. In addition to the location and design of the entrance, it's also important to consider the type of door that is used. The door should be designed to open easily and quickly without requiring excessive force or manipulation. It should also be equipped with a panic bar or other mechanism that allows it to be opened from the inside with a single motion, even if the door is locked from the outside. This ensures that personnel can quickly and easily exit the equipment room in an emergency without having to fumble with keys or other locking mechanisms. Moreover, it's important to ensure that the door is properly maintained and in good working order. This includes regularly inspecting the door for any signs of damage or wear, and promptly repairing any issues that are identified. It also includes lubricating the door hinges and other moving parts to ensure that the door opens smoothly and easily. By paying attention to these details, it's possible to create an electrical equipment room that is both safe and functional, providing personnel with a safe and reliable means of egress in the event of an emergency. Now, let's delve deeper into the rationale behind the exception allowing a single entrance when the working space is doubled. This exception is based on the principle that increasing the working space around electrical equipment reduces the likelihood of personnel being trapped or hindered during an emergency. When the working space is doubled, there's more room for personnel to move around and avoid potential hazards, making it easier for them to reach the entrance and exit the equipment room safely. However, this exception is not a blanket allowance that can be applied in all situations. It is only permitted when the increased working space provides a demonstrably safer environment and when the entrance is located in accordance with the requirements of NEC 110.26. C. In other words, the exception cannot be used to justify a poorly designed or unsafe equipment room. The equipment room must still meet all other applicable requirements of the NEC, including those related to lighting, ventilation, and fire protection. Moreover, it's important to note that the authority having jurisdiction, or OJ, has the final say in determining whether the exception can be applied in a particular situation. The AHJ may require additional safety measures or modifications to the equipment room to ensure that it meets the intent of the NEC. Therefore, it's essential to consult with the AHA during the design and planning stages of any electrical installation to ensure that all applicable requirements are met. In addition to the requirements of NEC 110.26 C, there may be other applicable codes and standards that must be considered when designing and installing electrical equipment rooms. For example, the International Building Code, or IC, contains requirements for the construction and fire protection of buildings, including electrical equipment rooms. The IBC may require specific fire-resistant ratings for the walls, floors, and ceilings of the equipment room, as well as fire-rated doors and other protective measures. Similarly, the National Fire Protection Association, or NFPA, publishes a number of standards that address the safety of electrical installations, including NFPA 70E, Standard for Electrical Safety in the Workplace. NFPA 70E provides guidance on the safe work practices and procedures that should be followed when working on or near electrical equipment. It also includes requirements for personal protective equipment, or PPE, and other safety measures that must be implemented to protect personnel from electrical hazards. Therefore, it's essential to be familiar with all applicable codes and standards when designing and installing electrical equipment rooms. By following these codes and standards, it's possible to create an equipment room that is both safe and compliant, protecting personnel from electrical hazards and ensuring the reliable operation of electrical equipment. Let's delve into the specifics of Table 110.26 to understand how to determine the minimum clear distance for working space about electrical equipment. Table 110.26 provides minimum clear distances based on voltage levels and conditions of the installation. The table is divided into 3 conditions, each of which specifies a different minimum clear distance. Condition 1 applies where there are exposed live parts on one side of the working space and no grounded parts or grounded parts suitably guarded on the other side of the working space. Condition 2 applies where there are exposed live parts on one side of the working space and grounded parts on the other side of the working space. Condition 3 applies where there are exposed live parts on both sides of the working space. The minimum clear distance varies depending on the voltage to ground of the exposed live parts. For example, for equipment operating at 150 volts to ground or less, the minimum clear distance is 3 feet for condition 1, 3 feet for condition 2, and 3 feet 1/2 inches for condition 3. For equipment operating at 600 volts to ground, the minimum clear distance is 3 feet for condition 1, 3 feet 1/2 inches for condition 2, and 4 feet for condition 3. Therefore, to determine the minimum clear distance for a particular electrical equipment room, it's necessary to first determine the voltage to ground of the exposed live parts and then identify the applicable condition based on the presence of grounded parts or exposed live parts on the other side of the working space. Once the voltage and condition have been determined, the minimum clear distance can be read directly from Table 110.26a. It's important to note that the minimum clear distances specified in Table 110.26 are just that, minimums. In some cases, it may be necessary to provide additional working space to ensure the safety of personnel. For example, if the equipment is located in a confined space or if there are other obstructions in the working space, it may be necessary to increase the minimum clear distance to allow personnel to safely access and work on the equipment. Moreover, it's important to consider the type of work that will be performed on the equipment when determining the appropriate working space. If the work involves complex or delicate procedures, it may be necessary to provide additional working space to allow personnel to perform the work safely and accurately. In addition to the minimum clear distances specified in Table 110.26a, the NEC also contains requirements for the width and depth of the working space. The width of the working space must be at least 30 inches, or the width of the equipment, whichever is greater. The depth of the working space must be at least the minimum clear distance specified in Table 110.26a. These requirements ensure that personnel have adequate space to safely access and work on the equipment. Let's shift our focus to the practical implications of ensuring adequate working space around electrical equipment. The primary reason for maintaining clear working space is to provide a safe environment for personnel who need to inspect, maintain, or repair electrical equipment. When working on energized equipment, there is always a risk of electrical shock or arc flash. Adequate working space allows personnel to maintain a safe distance from energized parts and to maneuver freely without coming into contact with hazards. Moreover, clear working space facilitates the use of tools and equipment. When working on electrical equipment, it's often necessary to use a variety of tools, such as voltmeters, ammeters, and insulated hand tools. Adequate working space allows personnel to use these tools safely and effectively without being cramped or restricted. Furthermore, clear working space enhances productivity. When personnel have adequate space to work, they can perform their tasks more efficiently and accurately. This can lead to reduced downtime and improved overall productivity. In addition to the safety and productivity benefits, maintaining clear working space also helps to ensure compliance with NEC and other applicable codes and standards. Failure to comply with these codes and standards can result in fines, penalties, and other legal consequences. Therefore, it's essential to prioritize the provision of adequate working space around electrical equipment. This can be achieved by carefully planning the layout of electrical equipment rooms, ensuring that there is sufficient space for personnel to safely access and work on the equipment. It can also be achieved by implementing procedures to keep the working space clear of obstructions such as tools, equipment, and debris. By taking these steps, it's possible to create a safe and productive environment for personnel who work on electrical equipment. Now, let's consider some common mistakes that can lead to inadequate working space around electrical equipment. One common mistake is failing to properly plan the layout of electrical equipment rooms. When designing an electrical equipment room, it's essential to consider the size and location of all equipment, as well as the space needed for personnel to safely access and work on the equipment. Another common mistake is failing to keep the working space clear of obstructions. Over time, tools, equipment, and debris can accumulate in the working space, reducing the amount of available space and creating hazards for personnel. It's important to implement procedures to regularly clean and organize the working space to prevent these obstructions from accumulating. A third common mistake is failing to provide adequate lighting in the working space. Adequate lighting is essential for personnel to safely see and work on electrical equipment. It's important to provide sufficient lighting levels and to ensure that the lighting is properly positioned to avoid glare and shadows. A fourth common mistake is failing to provide adequate ventilation in the working space. Electrical equipment can generate heat, which can make the working space uncomfortable and even dangerous. It's important to provide adequate ventilation to remove heat and to maintain a comfortable working environment. By avoiding these common mistakes, it's possible to ensure that electrical equipment rooms provide adequate working space for personnel. This can help to improve safety, productivity, and compliance with applicable codes and standards. Let's discuss the importance of regular inspections and maintenance of electrical equipment rooms. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical equipment rooms. Inspections should be conducted on a regular basis to identify any potential hazards or deficiencies, such as damaged equipment, inadequate working space, or improper lighting. Maintenance should be performed as needed to correct any deficiencies and to keep the equipment in good working order. The frequency of inspections and maintenance will depend on the type of equipment, the operating environment, and the applicable codes and standards. However, as a general rule, inspections should be conducted at least annually, and maintenance should be performed as needed based on the results of the inspections. During inspections, it's important to check for a variety of potential hazards, such as damaged insulation, loose connections, and signs of overheating. It's also important to check for adequate working space, proper lighting, and adequate ventilation. During maintenance, it's important to correct any deficiencies that are identified during the inspections. This may involve repairing or replacing damaged equipment, cleaning and organizing the working space, or improving the lighting or ventilation. It's also important to perform preventive maintenance tasks such as lubricating moving parts and tightening connections to prevent future problems. Regular inspections and maintenance can help to identify and correct potential problems before they lead to accidents or equipment failures. This can help to improve safety, reliability, and productivity. By prioritizing regular inspections and maintenance, it's possible to ensure that electrical equipment rooms remain safe and reliable for years to come. Now, let's consider the role of training in ensuring the safety of electrical equipment rooms. Training is essential for personnel who work on or near electrical equipment. Training should cover a variety of topics such as electrical safety, lockout/tagout procedures, and the proper use of tools and equipment. Training should be provided to all personnel who may be exposed to electrical hazards, including electricians, maintenance workers, and other qualified individuals. The frequency and content of training will depend on the type of work being performed and the level of risk involved. However, as a general rule, training should be provided at least annually, and a refresher training should be provided as needed to keep personnel up to date on the latest safety procedures. Training should emphasize the importance of following safe work practices and procedures. This includes wearing appropriate personal protective equipment, such as safety glasses, gloves, and arc-rated clothing. It also includes following lockout/tagout procedures to energize equipment before working on it. Training should also cover the proper use of tools and equipment. This includes selecting the right tools for the job and using them safely and effectively. It also includes inspecting tools and equipment before use to ensure that they are in good working order. By providing adequate training, it's possible to empower personnel to work safely and effectively around electrical equipment. This can help to reduce the risk of accidents and injuries and to improve overall safety performance. Finally, let's summarize the key points discussed in this video. We have explored the requirements of NEC 110.26. C regarding entrance and egress for electrical equipment rooms, with a particular focus on the exception allowing a single entrance when the working space is doubled. We have clarified that the entrance must be located such that the edge nearest to the equipment is no more than the minimum clear distance specified in Table 110.26 away from the equipment. This ensures that personnel can quickly and safely access the entrance without having to navigate an excessive distance within the equipment room. We have also discussed the importance of adequate working space, regular inspections and maintenance, and comprehensive training in ensuring the safety of electrical equipment rooms. By following these guidelines, it's possible to create a safe and reliable environment for personnel who work on or near electrical equipment.